Desalination!
So what is desalination?
Desalination is the Earth's hydraulic cycle, naturally working to purify water using solar energy.
Water is evaporated from numerous water sources, including oceans, lakes, and land surfaces, leaving salts behind.
The resulting freshwater vapor forms clouds that produce precipitation, which falls to the earth as rain and snow, and moves through soils, dissolving minerals and becoming increasingly salty.
Our experiment aims to replicate this natural process, removing the salt through the application of heat, which mirrors the action of the sun. First, we got our laboratory assistant, to collect approximately a bucket full of seawater.
Next, we measured the salinity of our water samples of both saltwater and household tap water using our portable refractometer.
The salinity of the tap water was 0%, which was expected, as tap water shouldn't contain salt.
The saltwater, on the other hand, produced a reading of 3.9%.
If our experiment is successful, this reading should decrease after desalination has occurred.
We used a digital multimeter to test each sample for resistance and conductivity.
We hypothesized that if the level of salinity of a water sample can be changed by the process of evaporation and cooling, then after desalination the level of salinity in the salt water sample will be decreased.
First, we take the bottom part of a coffee percolator and we are going to fill it up with about 1.5 cups of seawater. This will act as our storage device before the process of desalination has occurred. This will be placed above our heat source, in this case a stove. As the water temperature increases, water vapor will form.
But if the water vapor is rising, then where will it go?
We can use a filter funnel to channel the vapor.
And we can use this alfoil to keep it in place.
Exactly, and we can add some tape to hold it in place. Okay, let's attach a clear pipe to the filter funnel to channel the vapor through our coolant. Okay, now it's time to put it on the stove and see what happens.
To the kitchen!
With some help from our laboratory assistant, we were able to attach the pipe to the range hood. We then switched the stove onto medium heat. Now all that's left to do is wait for water vapor to form. After 15 minutes, we discovered that the gradient of the slope of the tube was too high, and that the air temperature was changing the water vapor back into water before it could reach the glass. This water was then falling back into the salt water container. To overcome this problem, we decided to lower the pipe so that the water would fall down the pipe towards the glass. After much anticipation, water began to flow into the glass. We then again tested the salinity levels of the water, and it produced a reading of 0%, meaning that we had successfully desalinated our salt water.